For this integral, we're supposed to use the substitution x equal 2 tangent of theta to evaluate this integral. So in other words, they're just telling you to use a trig substitution. So let's start off by finding dx. Instead of du, it'll be dx. That's my substitution. And the derivative of 2 tangent would be 2 secant squared theta. This will be d theta. So this is equal to, then, let's plug it in. Dx can be replaced by 2 secant squared theta d theta. So we're changing the variable from x to theta. We've got a 2 here and a secant squared theta d theta. Now the x can be replaced by 2 tangent theta. Okay, so this x right here, replace it by 2 tangent of theta. So we're transforming the integral into one involving the variable theta instead of the variable u, which is the typical one that we normally use. And then for this right here, under the radicand here, or in the radicand I should say, we got x squared, but x is 2 tangent theta. So right here, I'm going to put 2 tangent theta squared will give me a 4 tangent squared theta. Okay, so you were using plug it into the radicand here. And we got the 4 here. And then we're going to factor 4 out of that. Again, we're under the radical. We're working with the radicand. Tangent squared theta plus 1. So the x, we made the substitution already. And then for the radical here, this is your new radicand now. And we can take the square root of 4. That'll be 2. So that'll come out and multiply this expression there. And then tangent squared theta plus 1, you should recognize that as one of your trig identities. That's secant squared of theta. Secant squared, this is secant squared of theta. That's one of your Pythagorean identities. But we got that under the radical, so we take the square root of that. Don't have to worry about absolute values here. We'll assume we're dealing with acute angles. This will be secant of theta. So let's do this. This 2 here will divide out. This secant theta and this secant squared theta, this will reduce down to 1. So this is secant theta. So this will equal 2. And then I'm left with a 1 on top, and then the 1 and the 2 in the bottom will be a 1/2. I'll put this outside the radical, or the integral I should say. And this gives me then a secant theta d theta. And this is over tangent of theta. But I'm going to take that up to the top, and that'll give me a cotangent. So I'll do it this way then. The integral, tangent goes upstairs, it becomes a cotangent. Cotangent is cosine of theta over sine of theta. And then secant and cosine are reciprocal, so I can write the secant as 1 over cosine. So then the cosine and the cosine will cancel. And then I'm left then with 1 over sine. And then we come back over here. This is equal to, then, still got that 1/2 there. And it's the integral of, I'm left, this cosines cancel out, left with 1 over sine. But that's the same thing as cosecant. Cosecant and sine are reciprocals. So this is what I have so far. Let me clear some of this. Now we simply integrate this. This is 1/2 still. And there's a formula for the integral of cosecant of an angle. There's also one for secant of an angle. They're very similar. But in this case, we're integrating cosecant. This is going to be the natural log of absolute cosecant of theta minus cotangent of theta. And then it's plus the constant of integration. So again, I'm just using the formula, except there's one for secant and one for cosecant. I derived both of these in other videos, but these are pretty much ones that you should know. Now that's the integration. But remember, we started with an integral with the variable x. So we have to go back to the original variable. In order to do that, we need a reference triangle. So I'm going to draw a right triangle here. This will be theta. And we know from this right here, tangent of theta is x over 2. I divide through by 2, so tangent of theta is x over 2. So right triangle, tangent is opposite over the adjacent, so this will be 2 right here. And then complete the triangle here. The hypotenuse then would be the square root of x squared plus 4. This then is equal to 1/2 natural log, and then from the triangle I'll simply find out what cosecant of theta is. So the cosecant is the hypotenuse over the opposite side. So cosecant then from the triangle would be the square root. This would be x squared, square root of x squared plus 4. So it's hypotenuse over the opposite side, which is x here. This would be an x right here. And then it's minus, and cotangent from the right triangle of theta is the adjacent, which is x over the opposite. So I got then the final answer then is 1/2 natural log of the absolute value of the square root of x squared plus 4, or x minus 2 over x. And since we have the same denominator here, I could put this over x, and this will be a minus here. Absolute value of the square root of x squared plus 4 minus 2 over x. And that's your final answer here. Thanks for watching. We'll see you next time.